Nice having you on this platform. We'll continue with our 2001 JAM past question. Starting with question number 4. And the question goes this way. The diagram below is a block and tackle pulley system in which an effort of 80 Newton is used to lift a load of 240 Newton. The efficiency of the machine is... Okay, so you can see the question is centered on the topic machine. But the question targets to test something in the scholar. The question wants to know if you are aware that the VR, there is a concept called velocity ratio. The VR of pulley is the same as the number of pulleys in the pulley diagram. Okay, the question wants to know if you are aware that the number of pulleys on the pulley diagram as indicated on the board is the same as the velocity ratio. But recall, there is a formula for finding efficiency. And the formula says, okay, I'll be stating two formulas for finding efficiency. There are two formulas. The first one says, efficiency is equal to work output over work input times 100 over 1. This is synonymous or the same as efficiency is equal to MA over VR times 100 over 1. MA is a concept known as mechanical advantage. For something to be called a machine, it must have an advantage over man. Mechanical advantage. It must be taking advantage of gravity or length. MA, mechanical advantage. Then VR is another concept, velocity ratio. Velocity ratio. Okay, this is another concept in machine that targets to explain what differs machine from labor. What makes machine what it is. VR. For instance, using seesaw for example, it's been noticed that the greater length you take in seesaw, the person with the greater length is taking advantage. If you know the game we call seesaw, people target getting to the extreme of the bar. Because the more length you have for yourself, the greater advantage for yourself. That's the idea of velocity ratio, which is also regarded as distance ratio. Distance ratio or velocity ratio. But that's not our discussion for now. Let's focus on the question. So we can either solve using these two formulas. But from the parameters, we will know the formula that is favored most by our parameters. Okay, let's identify our parameters. Okay, we have efforts. Efforts. 80 Newton. Then we have load. 240 Newton. Then there's something I said earlier. There's another parameter that is hidden. Then go to the diagram. Count the number of pulleys. 1, 2, 3, 4, 5, 6. The diagram has 6 pulleys. Therefore, something is given there. Then VR is equal to 6. VR is equal to 6. Then the question becomes now, what parameter is favored? You can observe there is no work given. So this is out. So the best formula is efficiency equals MA over VR times 100 over 1. Because the concept called mechanical advantage, MA, is given in terms of load and effort. Recall, MA is equal to load over effort. The formula for finding mechanical advantage is load over effort. Therefore, MA is given 2. Okay, let's solve. Okay, let's get an MA. MA equals, the load is 240 over the effort is 80 Newton. Okay, observe, 0 cancels 0. 24 divided by 8 will be giving me 3. So my mechanical advantage is what? 3. Then I'll go further to find efficiency. Because that's the main question. We're asked to find efficiency. Therefore, efficiency is equal to, we'll go by this formula. What's my MA? 3 over my VR from the number of pulleys, 6 times 100 over 1. We take efficiency as percentage. That's why we multiply it by 100. Then let's go on. Okay, notice 3 over 6 is the same thing as 1 over 2 times 100 all over 1. Therefore, efficiency is equal to 50%. 50%. So do you think this is a nice machine? Do you think the pulley is a wonderful machine? Okay, so when you come to a perfect machine, from what we've solved, a perfect machine is 100%. So the pulley is half a perfect machine, because half of 100% is 50%. Thank you. Stay tuned as we go on.